Hello. Hello.
Hello?
Could you guys hear me? You can now? Okay. Because it came up and said that my microphone wasn't working. And I'm like, why is that happening? That's never happened before. So I'm glad you can hear me. Thank you for being my test. Whew. Okay, I am getting the homework assignment up so that we can, because today is questions on homework 1. So hopefully you have all had a chance to look over that.
And I'm gonna vote for you. But did you know that you and Ryan are both nominated for the court? And
So the way that I start these sessions is I take down question numbers that from the homework that you have questions on. So just either put your question numbers in the chat or just say them out loud, which problems you want me to go over from homework 1. Number 11. Thank you, Shannon. 19, 20. Thank you, Cassidy. Any others? Okay, that's all I see right now. There is room to add, should people come in and they want to add questions. So I will start off with those. So let me share my screen. So that we can all look together. It's problem number 11 is the first one that came up with a question. So this one's dealing with, it's 2 parts. It's dealing with the Fibonacci sequence, okay? So first off, let's talk for a minute about the Fibonacci sequence. So let me change for a minute to whiteboard. So the Fibonacci sequence is a sequence that goes 1, 1, 2, 3, 5, 8, 13, 21, 33. No, sorry, my bad. How do I get back to drawing? Eraser, I don't want eraser. I want to draw 30, draw line 34 and so forth. Okay. The idea for the Fibonacci sequence is that each term is the sum of the previous two terms. So the second term is 1 because 1 plus 0, because there's nothing in front of 1, gives me 1. And the third term is 2 because 1 plus 1 is 2. And the fourth term is 3 because 1 plus 2 is 3, and so forth. That's the pattern, okay, of the Fibonacci sequence. So I'm going to write that down. Cassidy number 7, but I'm already starting 11. So I'll go back. Not a problem. So, so that's first off the pattern of the sequence. So, let me change my sharing back to the problem. So the problem is saying compute the 3 missing sums for the equation shown here. What is the pattern involving the product of 2 numbers for determining the sum of consecutive Fibonacci numbers? So they're looking at what is the pattern that's created. So with this, so they're taking the sum of the squares of consecutive Fibonacci numbers beginning with the first Fibonacci number, form a pattern when written as product of 2 numbers. So that first line, 1 squared plus 1 squared equals 1 times 2, which is 2, okay? The second line, 1 squared plus 1 squared plus 2 squared equals, well, 1 squared and 1 squared that's 1 plus 1 plus 4, which is 6, and that's equal to 2 times 3, okay? And then the third line, so you're looking for a pattern, okay? So what they're saying is the third line, the first line was equal to 1 times 2. The second line is equal, that sum is equal to 2 times 3, which is 6. The third line, the sum is equal to 3 times 5, which is 15. So given that pattern, what do we expect the fourth line to be? Without even calculating what that sum is, what can we expect it to be? Is there a pattern that we can see? Four times 6. It looks like that's what it would be. 4 times 6, good Jennifer, is 24. And does that total equal 24 though? I'm not sure. I'm not sure I agree with 6, because it's looking at all of the digits of the Fibonacci sequence, and the Fibonacci sequence doesn't have 6 in it. So remember, it went 1, 1, 2, 3, 5, 8. So I believe it will probably be 4 times 8, which is 32. And that would make sense because 5 squared is 25 plus 3 squared is 9. 25 plus 9, I do it in my head, is, I don't know that it's going to be 8, because 4 times 8 is 32. But we've got 25 plus 9, because 3 squared is 9, plus 4 plus 1 plus 1, so plus 2. So we come out with a total of 25 and 9 is 34, 38, 40. So, so you know what? It's going to be 5 times 8. So it's going to be 5 times 8. Yes, which is 40. And so if that one's 5 times 8, what's the next one going to be? Again, looking at the numbers, it's going to be 8 times the next number, which would probably be 13. It's not going to be 4 times 8. It's going to be 5 times 8. So again, let's go back and look at new share. Let's go back and look at so this is the pattern of the sequence. So the first line was 1 squared 1 squared plus 1 squared, I think, which was 2. And then it was 2 times, so that, then it was 2 times 3, then it was 3 times 5, then it was 5 times 8. 5 times 8 gave us 40. The next one should be 8 times 13, and so forth. So that's the pattern that they're looking at, that you should see in that. So let me see. I did that wrong. Where do I want to go to now? I want to go back to here. So so what they're saying is, it's the first one says it's the product of the last Fibonacci number in the sum times the next to last Fibonacci number in the sum. And I'm not sure I agree with that. It's and then the second one, the product of the last Fibonacci number in the sum times the next Fibonacci number. And I believe that's what it is, because if you look at this one, that's 3 times 5, it's the last number in the sum times the next number that's going to show up in the Fibonacci sequence. So if I were doing this, I would choose B. Okay. And it liked me because it gave me a green check. And now it's saying use the pattern from part A to find the sum of the squares of the first 12 Fibonacci numbers. So they've given you the first 3, okay? Then they want you to find 4, 5, and 6. In part 2, they're saying use that same pattern that you're seeing to find the sum of the squares of the first 12 Fibonacci numbers. So you'd have to continue that Fibonacci sequence out till you get to 12 numbers. So what I had here was, how many did I have here? I had 3, 6, 9. I would need to continue this out to get 3 more numbers on here. And again, the pattern is this plus this gives me that, okay? And this plus this gives me this, okay? And then this plus this gives me this. And that's the pattern. This plus this gives me this term, okay? So you continue out that pattern. So the next number here would be what? In that pattern. Who can tell me what this number would be? Oh, I see 3 people in the chat. 55. Good. Sorry, I didn't get to my chat fast enough. 55. And then you're going to keep that out. So once you get to the 12th number, you keep going 2 more numbers, because what I've got 3, 6, 9, 12. That would give me 12. Then I've got to find out basically what the product of these, well, the 12th number, you'd have to actually take it out to 13 numbers, because you would have to find the product of this last number in the sum times this next number in the sum, right? And this is the 12th number. Okay. So that's how you'd have to solve it. B or D? Yes, I chose B. But yours may be, read it carefully, because yours may be random. They may not be the same as mine. So read it carefully to make sure that yours is saying that, because these programs randomly mix things up, right? So, because oftentimes my problem doesn't always, my multiple choice options don't always mic up with what yours are on your end, because they jumble them. Okay, so be sure to read it carefully, because you're taking the last number in the sum times the next number in the Fibonacci sequence. That's the pattern. Okay, so let me go here, new share. Let me go back to here. So that's 11. And so that's how I would do that one. And that was 2 parts. And that's that part. I'm not going to give you the answer to the second part, but I showed you what process to use to get there. So somebody had added on, let me just check the chat for a minute, because I know I don't always have a good chime going back up in a chat. I know question 7 was added, but okay, so no more questions were added after 7. So let me go back to 7. That was 11. So I'm going to mark that off my list. We did 11. So 7 says trick problems like the following are fun and they can help improve problem solving ability because they require that a person listen and think carefully about the information in the question. I see somebody's got something in the chat. You need to go through the long way, right? No shorthand. I should be using based on the number given for 11. I'm not sure I understand your question, Shannon.
I can turn my mic on for you. That might be easier. So I guess with those ones, there's a couple other ones too, where I just wanted to be sure I wasn't missing, like, because I could figure, okay, so 15, I know it's before that. I know it's before that based on my understanding of the Fibonacci numbers, but there's no like shorthand way to, based on the numbers that are given in the problem, to just solve for that one. I do need to write through and go through the entire sequence one by one, right?
You don't have to go through it one by one. Once you've seen the pattern, right? If you can carry out the Fibonacci sequence to you're going to have to carry it out to the 13th number, right? Mm-hmm. Because that product is the product of the last Fibonacci number, which they're asking you to go to the 12th number, right? Mm-hmm. Times the next Fibonacci number. Mm-hmm. So once you determine that pattern, so you just have to carry out that Fibonacci sequence to the 13th number so that you know what the 12th and 13th numbers are. And then you take the product of those, and that's going to be your answer.
Okay, cool. Thank you.
There's no shortcut way of getting there. Okay. And that's kind of the way it is with a lot of these problems. You have to kind of do the grunt work to get
right. Yeah. Good to know. That's what I was worried. I was like, am I missing something? It's supposed to be. Okay, great. Thank you so much.
Okay. So 7, let me take that down. So 7, these are trick problems. Take 4 apples from 5 apples. And what do you have? So these are kind of trick questions, just like they say they are. So you're taking 4 apples from 5 apples. And what do you have? What would you have? I mean, it seems intuitive that we would have 1 apple. But you're taking, balsam, it's kind of trick. You're taking 4 apples. That's what you have because you took 4 apples, right? So I would agree with that, 4. And then a farmer had 12 sheep, and all but 10, how do I take that down? And all but 10 died. How many sheep did he have left? So all but 10 died. He would have 10 left, is what I would think. So I have 2 US coins that total 30 cents. One is not a nickel. What are the 2 coins? So I gotta think about that one. I have 2 US coins that total 30 cents. Oh, we have choices. A quarter and a dime, that's 35. A quarter and a nickel. Oh, I see what they're saying. And one is not a nickel. So you could say they had I would kind of say one's not a nickel, so I would say they have a quarter and a penny, because it doesn't say how many of each coin they have. It just says they have 2 US coins that total 30 cents. So you could have a quarter and 5 pennies, and then you still have 2 types of coins, right? It's a quarter and a nickel still, because one is a nickel and a quarter. Because one isn't, you stopped, Cassidy. One isn't a nickel. Is that what you're saying? Yes. Okay. One is not a nickel and the other one is. Oh, gotcha. Okay. So they're looking at it that way. Okay. So these are kind of trick questions all the way down that you have to go through. So let me do this, check my work and see where I am thus far. It likes what we've got so far. I think the one that really tripped people up on this problem in previous quarters was the bottle of cider one. A bottle of cider costs $2.86. The cider costs $2.60. $2.66. I can't say it. More than the bottle. How much does the bottle cost? I got to think about this because this has tripped people up all the time. This is a bottle of cider cost $2.86. The cider cost $2.66 more than the bottle. How much does the bottle cost? So intuitively, we would think that the bottle costs 20 cents. But I don't think that's the right answer.
Excuse me. Excuse me.
Yes, awesome.
So I have the idea for this D. How about if we say the bottle is X and the cider is X plus 2.60?
2.66? So
Yeah,
you're saying you're gonna do, let me go to, you're gonna do this.
like this one.
You're
I
gonna
will write
say-
it in the chat.
You're gonna say
Yeah,
X
okay. X
plus
plus X
plus
plus
2.66.
no. For mine it is 60.
Oh, so you have a different number, but mine
Yeah.
says 266. So I want to use what mine is to be able to check it. So
Okay,
so we're saying that's, go ahead.
equal 2.90.
Okay, but mine was 286. So I want to stay with my number. So you had 260 and 290.
Yeah.
Okay.
290.
So this becomes 2x
2x
plus 266 is equal to 286. And we subtract 266 from both sides. And we get 2x is equal to 20 cents. And divide both sides by 2. And we get x is equal to 10 cents. So let me try it. Let's try it. I like your thinking. So let's give it a whirl. And see if it likes it. Because it wants it in dollars. So I'm putting 0.10. Now, before I do this one, somebody said they had problems with F, because if I hit check my work now, it'll check my work, but it won't let me do it 3 times. So let me look at F. A hen weighs 2 pounds plus half its weight. How much does it weigh? So this is kind of that same thing. I think 2 pounds plus half its weight. How much does it weigh? So let me see, clear. it weighs 2 pounds plus half its weight. And that equals the weight, right? And so I can change this to 0.5, but here I'll do that. It's going to be 0.5, its weight. So I'm going to subtract 0.5 W from both sides, because these will then cancel out, and I get 2 pounds is equal to, this is 1 W minus a half a W, which is a half a W. Okay. I divide both sides by a half. And I get that W is equal to 4 pounds. Does that make sense?
Yes.
Okay, so let me go back and put in 4 pounds. And let's see. Now I'll check my work. Okay. And we'll see what I get. It liked both of those. So these are, you got to think through them.
So excuse me, for G, it will be 10.
G, there are 9 brothers in a family, and each brother has a sister. How many children are in the family? I would say 10. Yes, because each brother has a sister. That doesn't mean that each brother of the 9 has a sister. It means that each brother has a sister. So yeah, I would say 10.
I see I see the numbers are different from my and you. So
Yeah,
is that okay?
Yes, that's how it is, Balsam. That's why I said be careful on number 11, because when somebody was saying, oh, what did she choose? She chose B. My B may be different than your B, because these problems are randomly generated. So my numbers will most likely never match up with the numbers that any of you have, because there's a whole library of this same type of problem, because you always have the option in these problems to try a similar problem. So there are other problems out there with other numbers. They just change the numbers. So don't ever go by the answers that I give you. We're in these sessions, we're really going over process rather than actual numbers, because my numbers are going to be different than yours. Just like that cider problem where you had $2.60 and $2.90, but I have $2.66 and $2.86, right? So my numbers are going to be different than yours. So you have to really come to these sessions looking for process on how to solve the problem. Now, it's not always that way. Sometimes my question will match yours exactly, because sometimes the problem bank doesn't have anything more than just that one question, but usually and typically they're different. Okay. So be very careful when we're going through these sessions. Make sure to read through your problem, because like I said in 11, my B may not be your B. My B could be your A, or it could be your D, right? So you have to look at the language of the problem and understand it. So Balsam, for E, how much dirt is in a hole 5 feet long, 4 feet wide, and 2 feet deep? I would say yes, their selection is no dirt, because it's a hole. Yeah. They're not asking how much space is in the hole. They're asking how much dirt is in the hole. And the children get asked questions like this all the time. They're really asking you to look at what information is the problem giving you and what is it asking you for. That's what they're trying to help you define here. So have we gone through most of these, enough of these that you get it? Hopefully. Yes, thank you. Okay, Cassidy, I don't know who asked for that one. So my next one on my list, can we go back to 11 for a minute? Yeah, sure, Shannon, we can go back to 11. What's the question with 11, Shannon? I'm still confused on the B part.
So yeah, I did what we were asking, while you guys were going through the last one, or what we went over, and I wrote it all the way out to the 15th and the 16th number, just so I could use both if I needed to. And it didn't, and then added those two together. So for one attempt, I added the 14th and 15th number together.
No, you're not.
And
No, wait. I'm gonna stop you. You're not adding the numbers together. You're taking the product of the two. So you're looking at the right side of the equation and you're taking the product of the two.
Okay,
You're multiplying them, not adding them.
okay. So then same, the 14th number was 377, the 15th was 610. I'd multiply those two together for the,
For the 15th, yes. For if you were asked in your problem to do the 15th,
yeah,
you would go take the Fibonacci sequence out to the 15th term,
mhm,
take it then to actually take it out to the 16th term, and to fit this pattern, you're going to multiply the 15th term times the 16th term.
okay. Let's
Yeah.
see. Yeah, I guess the wording on that one was what was really tricky for me. Let's see if it likes that one. Thank you. Okay. Thank you so much. We're good.
Okay, that worked. Okay, so now we're going to 19. So let's see what 19 says. 19, oops, I didn't mean to do that. I meant to take it all the way down. Okay, 19 says a 2,355 foot long straight fence has posts that are set 15 feet on center. That is the distance between the centers of two adjacent poles is 15 feet. I got to make a note of this. Two adjacent poles is 15 feet, or 15, I put 15 inches, 15 feet. And our total distance is 2,355 feet. If the fence begins with a post and ends with a post, determine the number of posts in the entire fence. So it looks to me like it looks to me like 2355 divided by 15. I'm going to do that first. Is 157, meaning that I would have, if I take 2,355 and divide it by 15 feet, I'm going to have 157 of those sections of possible 15-foot sections. But I want to look at this on a smaller scale. So let me show you on a smaller scale. Okay, so I've got a post. Okay. And I've got a post. And I've got a post. And in between these posts, it's 15 feet. Okay. So you have a post on the end here, and you're going to have a post on the other end. So here's what I'm going to show you. Okay. Let's say instead of having 2,355 feet, okay, I had 45 feet. Okay. So if I had 45 feet, if I divide 45 by 15, I get 3 sections. So I should have 3 sections that are 15 feet long, right? But do I have 3 posts? Am I showing 3 posts here? No, I'm showing 4 posts, right? So I had 3 sections here, but I have 4 posts because I have to have an end post on each end. And I have 2 posts between the 3 sections, right? So if I had in my problem, and your numbers may be different, it said I had 2,355 feet and I had 15-foot sections. Okay, so this is the number, 15 feet sections. When I divided that, when I said 2,355 divided by 15, okay, I got 157. So I'm going to have 157 of these sections. Well, here I have 3 sections. And in between those 3 sections, I have 2 posts. So I have 1 less post than I have sections. So given this example, it would make it seem like if I have 157 sections, I would have 156 posts in between them. But I also have to have a post on the end and another post on the other end. So I have to have 2 end posts. So it seems to me that I would have 158. But I want to test this a little further before I put my answer in, because I want to look at it in a different light, okay? I want to say, okay, what if I had 60 feet? I want to test my hypothesis and say, what if I had 60 feet, okay? So if I had 60 feet, I'm going to add 1 more post onto here, right? Because difference between 45 and 60 is that. So is 15 feet. So now in the brown, I would have 4 sections. Oh, that was a bad squiggle. There should be a little thing here. I would have 4 sections. And you see I have for the brown 3 posts in between the end posts. So I think my hypothesis would be true to say that for this amount of feet, 2,355 divided by 15 gives me 157 15-foot sections, meaning I would then have 156 posts plus the 2 end posts. So let me try it. Let me do a new share, go back. And hopefully my numbers are not the same as yours because I'm not giving everybody the answers. So I would say 158. And it likes me. And I like being liked. 20. Any other questions on 19? Does everybody get 19? Nobody's saying anything. I'm not seeing anything in the chat. So hopefully my drawing and my hypothesis and my testing worked.
For for question 19, how about this idea? I divided the number by the feet, the total by the feet, and the result for it, I make it +1 for the end post.
Yeah, you could do that too.
Okay.
That's the same kind of thing, but I just drew it out and showed it different. But it ended up being the same because I had 157 sections, but 158 posts. But that's how I wanted to show that's how they're coming up with it, right?
Okay.
Kind of. So yeah, however, this is the beauty of math. There are many different ways to get to the answer. And you will find this when you teach children, okay? I have had students who have come up with the most interesting methodologies for finding the answer that I would not have thought of, right? But they've done it and it's worked and it's right. And so it's exciting because that's just the beauty of math. You can come to a problem in a lot of different ways, but still get to the right answer. Okay. So number 20 is the next on my list. Oh, I have to mark 19 off. 20. On the first Monday in October, it is traditional that the 9 justices of the U.S. Supreme Court begin their session by each shaking the hand of each of the other judges. How many total handshakes is this? Okay. Oh, there's this problem, the handshake problem. So rather than use the 9 justices, okay, let's just think about, I'll change the number. You guys may not have the same number, but let's say I had 6. Okay, 6 people. Okay, so I've got 1, 2, 3, 4, 5, 6. Okay, so person 1, all right, if they're going to shake hands with every other person, okay, person 1 is going to shake how many hands? 5. Okay. So then person 2 is going to shake how many hands? Well, okay. I see you said 5, Cassidy. They've already shook hands with the first person. So they're going to shake hands with 4 people, right? Because they already shook this person's hand. So they don't have to shake their hand. And so they only have to shake 4 people's hands. And so person number 3 only has to shake now 3 people's hands because they already shook this person's hand and this person's hand. So they only have to shake 3 hands. And person number 4 has to shake 2 hands. Person number 5 has to shake only 1 hand. And person number 6 has to shake 0 hands because they've already shaken hands with everybody else. So when I add those up, I've got 5, 10, 15 handshakes. If I had 6 people, okay? And that's what you have to think about in solving this problem, okay? And sometimes it helps to draw it out, okay? If I were in a classroom of students, I would take 9 of them. If I had a problem like this and I had a classroom of students, I would take 9 of them and I would put them in a circle and I would say, okay, how many handshakes are there? And let them figure it out. Like put them in groups of 9 and let them figure it out and see. Or if you don't have enough students to give you groups of 9, take groups of 6, right? And split them up however you can to say, okay, first to solve this problem, let's see, how would we solve this with a smaller group? So I'm going to put you in groups that are this size. And I want you to investigate this, figure it out. How many handshakes does it take for you to have all shaken hands with everybody else? And then they can figure it out, right? Helpful? This is formula for handshake also. Yes, but here's the thing, Balsam. I liked your earlier formulas. They were great. But when you're teaching elementary school kids, they're not going to have algebra in their toolkit. Okay?
Of course, I mean for the check.
Yes. I mean, there is actually a formula for the handshake problem. But yeah, I would be reluctant to use, as much as you can in this unit, unless you absolutely have to, try not to jump to formulas because that's part of the idea of this this class is we've all taken, we've all done higher level math. So we understand algebra and we understand how we can substitute a variable in and we can solve for it. But when you're teaching elementary school kids, they don't have algebra in their toolkit. They haven't learned that yet. So you have to have them think about how to solve problems without being able to make that leap into the realm of algebra. How would I solve this if I didn't have algebra? It's not always easy. It's not always right on the tip of your tongue, right? And it's not always something that you can come up with. But that's where we're wanting you to take your mindset in dealing with these problems, especially in this first chapter, this first section, because it's all about problem solving. What goes into a problem? What are we looking for? What is the problem asking? What don't we know? Figuring all of that out and then finding a way to get to that without invoking things that are beyond the realm of the students we're teaching, right? So I think I want to go back. I want to do another share because I want to go back to, I think it was in problem number 11. Was I right? Was it problem number 11? Where was it? Nope, it wasn't 11. It was 7. I think it was 7. Problem 7. I forget which one it was, but Balsam, you used the algebra to, oh, it was the bottle of cider problem. Yeah. And so with that problem, historically with this class, we have had to invoke algebra to solve that bottle of cider problem because we have an unknown and we have to have some way to represent the unknown. So we throw in a variable. But it's hard to think about that. How would you solve that bottle of cider problem with students when they don't know what a variable is? How would you explain that to them? And that's the tricky part, is trying to break that down for them. And yeah, it is how we know the algebra, we can check our work, but how do they check their work, right?
Yeah, I mean for us, like for students and for the class, not for children.
Yeah, but we
Yeah.
have, but that's what that's what I'm saying. A lot of these problems that you're going to see throughout this course, you're going to want to go to algebra. And honestly, if you go to the guided solution, they're going to go to algebra in some of these, in some of them, not all of them. But for the most part, you have to try to quell that desire to want to pull in algebra, because you've got to think about this like, okay, if I were in 3rd grade, how would I solve this problem? And it's not an easy thing, but for some of them, you don't have an option because you kind of have to go there, right?
Mhm.
So that's the thing to think about. And here's what I want to point out to you. Remember when I first did question 7, this is why I say be careful when I go through these problems with you during these sessions. When I first did this pulled this problem up, remember my bottle of cider in that problem cost $2.86 and the cider cost $2.66. Now I've pulled it up again in this preview and I've got $2.90 and $2.70, right? So my numbers will not always match your numbers. And here I have 7 brothers. And before I had 9 brothers. And here I have 3 pounds. And before I had 2 pounds. So my numbers are probably never going to match yours, or they might match one of yours in the whole group of the class, right? So any other questions that you see from the homework that you want me to go over? Hold on, Shannon. Anyway, we would have time to look at the try this activity 4 in the lecture, or should I make an individual appointment with you? Try this activity 4 in the lecture. In lecture, which one? In 1.2 or 1.2? I could see if I could pull that up. Hold on. The try this for the models. Okay, let me see if I can pull that up. Hold on. Oh, you know what? I have that file. Give me a second. One point two. So let me go back. You're saying it's which, oh, Balsam, you have a question on, I'm sorry, I got away from chat. You have a question on questions part C and D and question 5 in the homework, right? Let me look at that first. Let me go to that first. Hold on. And you're saying activity 4 of the try this. Okay. So first let's go to the connect problem number 5. Part C and D, unfortunately, oh, I can see them. Suppose you have a supply of red, blue, green, and yellow tiles. What is the fewest number of different colors needed to form a 3x3 square of tiles so that no tile touches another tile of the same color at any point? So now they're going down to C. Suppose you put a blue tile in the center and a red tile in each corner as shown here. What is the smallest number of different colored tiles needed for the remaining openings? Where's the square range shown here? Not a correct solution. So, so that no tile touches another tile of the same color at any point. And so now you're going to, your question was on C and D, Balsam?
Yes.
Suppose that you put a blue tile in the center and a red tile in each corner as shown here. What is the smallest number of different colored tiles needed for the remaining openings? Well, wouldn't it be 1 to look like the one above? That doesn't work. Because it would touch.
Yeah, I try to do it and get like 2 or 1. So I confused a little bit for this part.
Let me see. I would say 1. Because if I go up above, if I were to put yellow in each of these, then it's not touching a yellow one. So let's see if it'll like it. No, it doesn't like it. Square of 9 tiles so that no tile touches another tile along an entire edge. Wait, does C have to do with B? No tile in the center. And so we have to have no, so that no tile touches another tile of the same color at any point. Oh, so it can't touch the same color at any point. I see. So they're talking about not edge, but point. So we would have to have, I got to think about this. If I did a green and I did this and I did a green and I did this. So you would have to have 2, I think. Let me see if it likes that. Yes, it likes 2. And here's why, because if I put Am I sharing my screen? Are you guys, sometimes I forget to share my screen and I'm not sharing my screen. Sorry. Sorry about that. So it can't be 1 because they're talking about it can't touch at a point the same color. So I was thinking 1 because I was looking up above and seeing, okay, well, they don't touch the same color, but then they're saying that's not a correct solution. So the correct solution would be at any point, they can't touch the same color. So I would have to have 2 different colors. So if I put, oh, here it is. If I put a green tile here and an orange tile here, and a green tile here and an orange tile here, they're not at any point, they're not touching the same color. So it would have to be a minimum of 2 to make that work. So then suppose the problem had asked for the smallest number of colors to form a square of 9 tiles, which is the same number of tiles, so that no tile touches another tile of the same color along an entire edge. Now you're talking about edges. And I believe that would be 1 because I think that first tile up here would fit that because no tile touches another tile the same color along the entire edge. So this one in A would fit that. And I think that 1 would work for that because it doesn't, none of these tiles touch the same color along any edge. So the color that is the same as it. Does that make sense, Balsam?
Yes. Yes.
Okay. So let me go back to this try this problem. So you're talking about try this activity 4, and I don't know what screen that's going to be on. So that's the summary. So it can't be that one. Is this it?
I think she means on the ebook.
Oh, on the ebook? Let me see.
On the PowerPoint that you put up.
On the PowerPoint that I put up. So it's this one?
I'm still seeing the online homework on your screen.
Oh, sorry. Oh, my bad. Okay. So which one is it?
Okay, so looking for, so I think, so this is 1.2. Oh, I guess it was 1.1 then, because I haven't done the 1.2 yet in my
so
journal.
let me pull up that file. Hold on.
Thank you. Sorry.
That's okay. It just takes me a minute. Screen sharing is stopped. Okay.
Because we need to have all of these try this activities in our journal, correct? Like along with our notes.
I want you to have those in your journal and clearly marked so that I can see them, because when I do a journal check, I will probably ask to see or try this, and I need you to be able to show me them. So let me go back to sharing my screen because I've got this new PowerPoint up. So which try this is it?
It's the 4th one about the models. So I think it might be just under that one because that one was a short one. Yeah, number 13, I think, or slide 13. So it has to do with this one, whichever try this is associated with this.
Okay,
It's
but
the
it
models.
references, okay, so this try this. Yes, so this is a problem like you're gonna see in your test.
Is that the last, wait, I'm sorry. Is it the last try this or is that?
No, the last try this is on 16.
Okay, perfect. Thank you.
Is this it? The one you have a
Yes.
question?
No,
Okay.
no, the one you had up before was the right one.
Oh, okay.
Yes, you got
So
it. Thank you.
you're actually going to have a problem like this on your test. So it's important that you understand how to do this. And they're showing you a couple of different models in which to get to this idea of how to find the sum of numbers from 1 to n, right? And so it's important, and your tests are like take-home tests, right? They're open book, they're open notes. So I'm going to say direct your attention to this formula, because this formula is what you need to use to solve those types of problems. So they're telling you, where did they start with this problem? Using a model. So they're saying, what is the sum of numbers from 1 to 100? And they're saying devise a plan. One method would be to cut out staircases representing the numbers from 1 to a given number. The first stair represents 1, the second represents 2, and then they go to the next slide and they show this stair step model, right? And it says, what do the red squares represent in the sum? What do the blue squares represent in the sum? How big is the entire rectangle? So the red squares represent 1, they're going by stair steps. So 1 plus 2 plus 3 plus 4. And the same thing happens on this side, right? And so the entire rectangle is a 10 by 11, they're saying. So the sum from 1 to 10 is exactly half of the entire rectangle that is 10 by 11. So that's one way of modeling it to try to figure out how you could find the sum, right? And so what they're saying is they're giving you this formula. The sum from 1 to n is n, the biggest number you're looking for, times n plus 1 divided by 2. And then they're coming over here and they're showing you another model called the rainbow method. So they're saying, well, you could take 100 plus 1, that's 101. 99 plus 2 is 101. 98 plus 3 is 101. So each one of these arcs has a sum of 101, and there's 100 of them, right? There's 100 arcs. So you've got 101 times 100, but then you have to take half of that because you're duplicating in there. And so that's why you divide it by 2, because you're doing a duplication in that process. Does that make sense?
Yeah, it makes sense when you're looking at the rainbow method.
Yeah, the stair step is a little more difficult, but the rainbow method kind of makes a little more sense.
So when looking at the rainbow method, so each arc would be 101, and then you times it by half of itself, because in comparing it to that rectangle, it's only half of the equation,
Right.
half of and then, okay, so 101, the
But you
total
got
times
100 of it.
half of it.
Yeah.
Okay. So then the sum from 1 to 30 would be 31 times 15.
Yeah.
Which would give you the 465. Okay, that makes sense. And
Yeah.
which part on the try this, which method did you want us to be writing down in the journal for that?
I don't care.
Okay,
Whichever
cool.
one you understand.
Okay,
Whichever one's going to help you when you see this question on the test, because there is a question like this on the test.
okay, got it.
Formula in your toolkit, and I know it has algebra, and we know that third graders don't have algebra, but with this particular problem, you have to have the algebra.
Okay, great. Thank you so much. That was really helpful.
You're welcome. So we're 3 minutes past our time. I hope I've answered everybody's questions. I know we only went through 5 problems on the homework, but those are really the 5 that are the hardest. That's typically what happens during these sessions, is we really focus on the harder problems that you have in each assignment. So the next, and I'll be honest with you today, I almost would have forgotten this meeting, because, and I have to thank a student that I don't even think is here. She may be. Tabitha asked me about some assignments, and then I think it was Faye had asked me about other assignments. So I went in because the due dates were wrong, and I had a note to myself on my desk to say, set all math 171 assignments, non-connect assignments, and update modules week 2 through 12. I still haven't updated the modules week 2 through 12. I will do that on Sunday. But so I'll keep this note on my desk, but I was updating the due dates on the assignments. And I was looking at the calendar to do that. And all of a sudden I looked at the calendar and went, I have class today. Oh no, I have an appointment at the same time as class. So I had to reschedule my appointment. And then I realized I had not put any of our class sessions on my calendar. So I now have all of our class sessions on my phone, on my calendar, which I live by. So I will be sure to be here. So our next class session is on Thursday at 1 o'clock. It is our test social. On that same day, your homework 1 is due, okay? So you can come prepared with questions on your test at that point. Right now, your test should be available to you in Canvas. So you can either print that out or have it on your screen, and you can start to work through it and see what questions are going to give you a headache. But I do know, I can tell you that that one question that we just looked at from the PowerPoint, there is one of those on the test. So we essentially have already talked about it and gone over it. So I just saw Shannon put something in the chat. Exit ticket 2.1 said it's due on 9/28, but reading 2.1 isn't open till 10/1. I just changed that. Does it still say that? Because I just changed exit 2.1 to be due on the 5th, at the last day of lesson 2.1. So yeah, so check, because I changed all those. I changed all of the assignments that are in Canvas to the right dates now. So that's my bad, because I had not gotten to that yet. I still had this note on my desk. So I did that part of the note, but I have not updated my weekly introductions to each week in Canvas. So, so that I still have to do. So I will keep this note on my desk to do that. And that will get done probably by the end of the week. You'll definitely have the one for week 2, but hopefully I'll have all of those other weekly introductions done so that I can just get it off my plate for the rest of the quarter. So that's it, people. I hope you have a great day, and I will see you on Thursday with questions on your test. Remember, I record each of these sessions, and once it's downloaded and I find it, because it downloads onto my computer and then I have to go look for it. But once I find it, I post it in an announcement on Canvas. So if you miss any session or you want to go back and review it, it should be there in an announcement in Canvas. Okay. All right. Have a good day. See you later.
Thank you.
You're welcome.
I have a quick question, if that's okay.
Yes, who is this?
This is Emily.
Hi, Emily.
So for the reading 1.2, I did it yesterday when it opened, but it didn't save for some reason. And so then I was on Canvas today and it said that I didn't do it. But I went back in and I redid it. But I didn't know if like that still counted. I don't know if like it was like an internet error or.
I'm not sure. If we don't, did you check to see if it updated in the gradebook in Canvas once you,
Because I went back to make sure it was there and it wasn't, so I just redid it real quick, and then it said that I wasn't gonna get credit for it, so I don't think it was gonna update in Canvas.
Okay, so I'm gonna make a note of that because I will check it in Connect. And then if it is done in Connect, I will make sure that you have those points in the gradebook in Canvas. Okay, so it's reading 1.2.
Yeah.
Okay, all right. Check on reading 1.2. I can do that right when we're done. I'll check on that.
Thank you so much. I really appreciate it.
No problem. Thank you for bringing it to my attention. And had we not had this meeting today, it's perfectly fine for you to pop me an email about that and say, okay, Miss Simmons, I thought I finished this out, but it didn't sync with Canvas. Did your, one question I would have, did your reading 1.1 sync with Canvas? Is there a syncing?
It did. Yeah, my
It did.
1.1 did, but it wasn't my 1.2 for some reason.
Okay, so just if that happens again in the future, just pop me, if we're not in a class session, just pop me an email about it and I will go and check it. As long as I can see that it's done in Connect, then I can go ahead and put the points in Canvas. But it should automatically sync, so it could be, who knows? It could be that you did it when Canvas was in a downtime, and so it didn't. That, you know, sometimes that happens.
Yeah.
So,
Okay. Thank you. Have a great day.
okay, we're done. Have a good day.